Hello students, welcome to Stuti Academy. Welcome you all another session of chapter number 1 of Matter in Our Surroundings chapter. I am Poonam Sharma here again to solve all your queries related to this chapter. Now in previous session, I have already discussed about properties of matter. What type of questions can come on the basis of this topic? In different states of matter, solids, liquids and gases, what kind of arrangement of particles are present in them. And apart from these three states, I have already discussed about plasma and Bose-Einstein condensate state also. So it means we have 5 states: solid, liquid, gases, plasma and Bose-Einstein condensate. This I have already discussed with you. I hope this topic is clear. Then this also I have clear, like how state of matter are changes from one form to another form. Like solid changes into liquid and liquid changes into gases. If we increase the temperature, solid changes into liquid or liquid changes into gases. Or if we reduce the temperature, the gases changes into liquid and liquid changes into solid. So what is the effect of temperature on the change of state of matter? This I have already explained in previous session. And these type of questions asked in exam: melting and boiling point. What is melting point and boiling point also? This also I have already explained, and why boiling point is known as bulk phenomena. And the answer for this is because when we provide heat, maximum number of the molecules of liquid takes up the heat and vibrate and convert into vapors form. Latent heat also I have explained to you. I'll just repeat this latent heat again. And latent heat is also known as hidden heat. With the help of an example, I'll clear this latent heat topic to you. If you remember in previous class, I told you, if we take any solid substance and then we place a thermometer, this is thermometer, and when we provide heat, then we observe that earlier the temperature here was 0 degrees Celsius, and when we provide heat to it continuously, so this temperature remains 0 degree only until and unless the entire solid changes into liquid form. So this shows that it means some heat is present here, but this heat is utilized by the particles in the changing of the state, but there is no rise in the temperature, and this kind of heat is known as latent heat. We have two types of latent heat of fusion and latent heat of vaporization. So first I'll discuss latent heat of fusion. Latent heat of fusion is that amount of heat which requires to change 1 kg of a solid into liquid on melting. So this kind of heat is known as latent heat of fusion of that particular solid. As just now I told you, when we provide heat, as you can see here, there is no change in the reading of the thermometer. It remains as it is. But if the entire solid converts into liquid form, then there is a rise in the temperature. So this kind of heat is known as latent heat of fusion. which is involved in the conversion of solid state into liquid state at its melting point. And if, do you remember what is melting point? Yes? The melting point is that temperature at which the substance starts melting at the atmospheric pressure. Yes, I hope this topic is clear to you. If you have any query, please write in the chat box. Yes. So we have latent heat and latent heat of fusion and latent heat of vaporization. Okay, now second is latent heat of vaporization. Latent heat of vaporization means the amount of heat required to change 1 kg of a liquid to vapor state at its atmospheric pressure. This and its boiling point. So this kind of heat is known as latent heat of vaporization. It means here liquid is involved, which is converting into gaseous form. I think this topic, latent heat of fusion, latent heat of vaporization and latent heat is clear to you. If you have any query, please children write down in the chat box. And what type of question can come in exam on the basis of this topic? I'll just have one question in front of you. Here, a student heats a beaker containing ice and water. He measures the temperature of the content of the beaker as a function of time. Which of the following figure would correctly represent the result? Justify your answer. Here in front of you, 4 beakers are there. In 4 beakers, our student heats ice and water together. And when he heats it, in first beaker you can see, first the temperature rises, then it becomes constant. In second one, first it is constant, then it decreases. In third one, first is decreases, then it becomes constant. And in fourth one, first it is constant and then it increases. So this question is based on latent heat. As I told you, some latent heat is present there, which is responsible for converting one state into another state. So D is the correct answer. And why D is the correct answer here? Any idea? Okay, I'll just explain you. In this D part, as you can see here, that latent heat which is present in the ice is utilized to convert the entire ice into liquid form, into water form. And then the temperature remains 0 degrees Celsius. The reading shows in the thermometer is 0 degree only. And when we continuously provide heat, so its temperature increases. Once it completely converts into liquid, then only it changes and its temperature rises. So that's why D is the correct answer for this. Now another factor which is responsible for the change of states is pressure. When we apply pressure, there is a change in the state. It results in the departing the molecules. So what happens when we apply pressure? Carbon dioxide gas can be solidified by applying pressure, which we call dry ice also. So when we apply pressure on any state, its molecules contract and changes into another state. Here you can see when we apply more pressure, so carbon dioxide gas solidified and it becomes dry carbon dioxide gas. Another another important factor or phenomena that is very important process is evaporation. Evaporation is that phenomena or the process in which the liquid changes into vapor state. In this process, for example, when we take water in a beaker and we provide heat to it, then we can see some vapors are start rising from that liquid. So that process is known as evaporation. Some more, see, this is a beaker and here I have taken some liquid. When I provide heat, it changes into vapors. This is evaporation. Okay, and if I place a lid over it, so these vapors convert into liquid form again. This is known as condensation. And this process is known as condensation. So we are talking about evaporation. So evaporation is that process in which the liquid state changes into vapor state. And the reason is when we are providing heat, so the particles or the molecules of the liquid, they start gaining kinetic energy and start vibrating. As you can see in the liquid, particles are far away. So when we provide heat, they gain kinetic energy. As a result, they vibrate more and creating more space between them, which results in the gaseous state. Evaporation is a surface phenomena because when we provide heat, the maximum amount of the particles from the surface of the liquid, they start gaining kinetic energy and convert into gaseous form. So that's why we call evaporation a surface phenomena. So I hope this evaporation process is clear to you and why we call it surface phenomena. It's a very important topic. 2 marks question comes on this, why evaporation is called a surface phenomena or what is evaporation. Now what type of question can come? And the question is, why is evaporation a surface phenomenon? As I told you, because when we provide heat, the particles of the liquid state, they start gaining kinetic energy, which results in vibrating the molecules or the particles of the liquid from the topmost layer of the surface. So that's why it is called a surface phenomenon. Students, it's a 2-mark question. It's very important question. And if you have any doubt in this topic, you can write in the chat box. Okay, so I'll repeat again this evaporation. Yes, evaporation is that phenomena in which liquid state changes into gaseous state when we provide heat to it. And when we are providing heat, the particles of the liquid starts gaining kinetic energy, which results in vibrating the molecules or the particles of a liquid and results in the changing in the state. And evaporation is called a surface phenomenon because when we provide heat, particles gain energy, affect the rate of evaporation. And these factors are surface area, temperature, humidity, wind speed. These are the 4 factors which plays a vital role and they have effect or they have adverse effects on the rate of evaporation. I'll discuss these factors one by one in detail. First is surface area. Surface area, the area taken up by the surface. The surface, it means the area taken up by that particular liquid is known as its surface area. So if surface area increases, the rate of evaporation increases. Surface area and evaporation, they both are directly proportional to each other. For example, it is very easy for us to sip a tea, milk or coffee, any hot substance, any hot beverage in a saucer. If we take any substance in a saucer, here the saucer and here some tea is there, and on the other hand I have one cup. In this also tea is present. So out of these two, in which one we can easily sip the tea? Or in which saucer, or in which one? I mean in saucer or cup? It is very easy for us to drink tea. Yes, please, just write on the chat box. Yes, of course, in the saucer one. What is the reason behind it? The reason is the surface area. Because as you can see, the surface area of this saucer is more in comparison with the cup. So more the surface area, more will be the rate of evaporation. I'll give you one more example. If you spill some water on the floor and just have some water in a bucket and keep it in the sunlight, out of these two, in which one you will observe the level of the water decreases at a much greater speed? Yes, please tell. Yes, of course. In that tub in which water is there, or we spill water on the floor. So in that case, the rate of evaporation is more in comparison with the water which is in the bucket. So because when we spill water on the floor, the surface area of the liquid increases, and in bucket the surface area of liquid is less. So if we increase the surface area, the rate of evaporation also increases. Next factor is temperature. Temperature is also directly proportional to the rate of evaporation. If we increase temperature, rate of evaporation also increases. For example, when you are heating a liquid, it can be milk, it can be water, anything. And if you provide more heat, you'll observe that that liquid starts boiling and converting into vapors form more quickly. And if you reduce the stove, if you reduce the temperature, it will take more time to boil that water. So it means if we increase the temperature, the rate of evaporation also increases. So surface area is also directly proportional and temperature is also directly proportional to the rate of evaporation. Next factor is humidity. Humidity is the presence of water vapors in the atmosphere. If already water vapors are present and the liquid particles which are moving up, they'll get less space. So it means if more humidity, the rate of evaporation decreases. So it means they both are inversely proportional to each other. It is just opposite to temperature and surface area. As I just now have explained you, like if we increase the surface area, rate of evaporation increases. If we increase the temperature, rate of evaporation increases. But if we increase humidity, the rate of evaporation decreases. For example, during rainy season, already water vapors are there. So during winter season also, your clothes will take more time to get dry in comparison with the summer season. So it means humidity is inversely proportional to the rate of evaporation. And the next factor is wind speed. More the wind speed, more will be the rate of evaporation. Because if the wind speed is more, it takes up more of the liquid particles and it results in the conversion of the gaseous state. So out of these four factors, only humidity is that factor which is inversely proportional to the rate of evaporation. Otherwise, surface area, temperature and wind speed, they all are directly proportional. Now I'll ask just one question to you. Suppose we have two beakers. I'll just draw these two beakers here. One, this beaker is A and this is beaker 2. Now I have water in this one and in this one also. Out of these two, if I'm providing heat to A as well as B, in which of the beaker the rate of evaporation is more? Yes, please tell the answer. Write in the chat box. Absolutely correct. Yes, so in A, the rate of evaporation is more in comparison with the B, because the surface area of A is more and the surface area of B is less. It's very important topic of this chapter, and reasoning question can be asked in exams on the basis of these factors. Evaporation is also known as the cooling effect. It causes a cooling effect. And the reason behind it, when evaporation process takes place, it takes up the heat in the upward direction, which results in the cooling of that surface area. So that's why we call evaporation a cooling effect. It results in a cooling effect. And that's the reason during summertime, during summer season, when the temperature is too much, sometimes shopkeepers sprinkle water in front of their shops. Because when they sprinkle water in front of their shop, then it gives a cooling effect in that particular area. Now, what type of questions can come in exam? Question number 1 is, why do we sprinkle water on the roof or open ground in summer? Similar question which I have just explained you. Why we sprinkle water on the roof or open ground in summer? See, as I told you, during hot summer evenings, what happens? The temperature is quite too much, and we need to lower down the temperature or reduce the temperature. So when we sprinkle water, the water evaporates by absorbing heat from the ground. So wherever the water is, we sprinkle the water there, and when the evaporation takes place, the heat is absorbed from the ground and from the surrounding air. So if they are losing the heat, the ground on which we sprinkle the water, if it loses the heat, it gives the cooling effect and we feel comfortable. So that's the reason why we sprinkle water on the roof or open ground in summer. I hope this question is clear to you. If you have any doubt, you can ask. It is similar to that question which I just explained to you. Now the next question is, explain how the rate of evaporation of a liquid is affected with increase increase in temperature of the liquid, decrease in exposed surface area, increase in moisture in the surrounding air, increase in wind speed. So in this type of question, you have to tell what factors, these factors like temperature, surface area, humidity and wind speed. These factors, how they are responsible in changing the rate of evaporation. As I told you, if we increase temperature, the rate of evaporation also increases. And if we decrease the surface area, the rate of evaporation also decreases. Increase in moisture, here moisture means humidity. More humidity, less evaporation. Increase in wind speed, increase in rate of evaporation. So answer is rate of evaporation increases with rise in temperature. They both are directly proportional. Temperature is directly proportional to evaporation. Then surface area, if here decrease in exposed surface area, it means in this case we are decreasing the surface area. So if surface area is less, evaporation is also less, because surface area is also directly proportional to rate of evaporation. Then less evaporation if moisture content is high in the air. It means if humidity is inversely proportional to the rate of evaporation. And if we increase the wind speed, it is also directly proportional. So these four factors plays a vital role in the rate of evaporation. I hope these two type of questions are very much clear to you. And if you have any doubt, please tell me. Please ask your doubt if you have related to this topic. Now here we have certain quantities. These quantities which we use in our daily life for the measurement. First is temperature, then we have length, mass, weight, volume, density, pressure. These are known as physical quantities because we use these physical quantities for the measurement of the physical substances. We are not measuring anything else like temperature. Temperature tells the hotness or coldness of a substance. And its unit is Kelvin and symbol is K. Although temperature is also measured by Celsius and Fahrenheit. Celsius and Fahrenheit. These two are also units of temperature. But Kelvin is the SI unit. SI unit means Standard International Unit. Standard International Unit. Standard International Unit means this unit is applicable worldwide. And why there is a need of creating this SI unit? Because earlier when scientists were doing experiments, whatever results they were having, so if they are performing their experiment in different areas, so if the different areas are using different quantities, so it is very difficult for them to measure it. So that's why after that it came into existence that a standard international unit was declared. So these units are applicable worldwide. So if we are measuring temperature in any part of the world, we always measure in Kelvin. So that's why we are using these SI units, which we call them Standard International Unit. Another unit is CGS, that is centimeter, gram and second. So these are the CGS units. Now second quantity is length. Length can also be measured in centimeters, kilometers, millimeters. But if we are talking about SI unit, which is standard international unit of length, it is meter, which is represented by this symbol small m. Then we have another unit, which is mass. Mass can also be measured in grams, but the SI unit is kilograms. Mass can also be measured in milligrams, grams, but SI unit is kilogram, and which is represented by this symbol kg. K is capital and G is small e. Next is weight. The SI unit of weight is Newton, and its CGS unit is Dian. Its CGS unit is Dian. And this symbol of Newton is capital N. Weight is a kind of a force that we will discuss in forthcoming chapters in detail about weight. So weight is a kind of a force. So it's a force. So that's why its unit is Newton, because the unit of force is also Newton. Now next quantity is volume, and its unit is cubic meter. If you remember, I told you about volume. Volume is the space occupied by a substance, is known as its volume, and its unit is cubic meter. It is represented by the symbol meter, small m, and we write cube like this. Then we have density. Density is mass upon volume. I just write here, density is mass upon volume, and the unit of mass is kg. Just now I told you, and the unit of volume is meter cube. So the unit of density is kilogram per cubic meter. So the unit of this is kilogram per cubic meter, which is represented by this symbol, this one. I hope these quantities till here are clear to you. And the next quantity is pressure. Pressure is measured in pascals, and the symbol is PA. So these are the physical quantities which we use to measure substances, and these are their SI units. And how we represent them, these are their symbols. And if you have any doubt related to this topic, you can ask. You can write your doubt in a chat box. So today we have done latent heat of fusion, latent heat of vaporization, and what is latent heat. I have already discussed this question with you on the basis of latent heat. Then what effect pressure has on different states of matter when one state changes into another state. Apart from pressure, temperature also plays a vital role in changing the states of matter. Then I have discussed about evaporation and why evaporation is known as a surface phenomena. This also I have explained, because when we provide heat, it has high kinetic energy and it takes place on the surface. Then what are the factors which affect the rate of evaporation? Surface area, temperature, humidity, wind speed. So these four factors plays important role which affect the rate of evaporation. And out of these four factors, only humidity is the factor which is inversely proportional to the rate of evaporation. Otherwise, all three factors are directly proportional to each other. And evaporation causes a cooling effect because when evaporation takes place, it takes the heat from the ground and gives a cooling effect. And what type of question can come? Generally, reasoning questions can come in the exam on this evaporation. Like, why do we sprinkle water on the roof or open ground in summer? Or why shopkeepers sprinkle water in front of their shops during the summer season? Or why clothes get dry easily in summer in comparison with the winter? So these type of questions can come on the basis of this evaporation. Or explain how the rate of evaporation of a liquid affected, and might be one or two factors can ask, or all the factors, or question can be asked in this manner, like write all the factors or name the factors or explain the factors. So it depends on the question. Then only write down the answer accordingly. If only the question demands explain the factors responsible for the rate of evaporation. So in this you have to explain all the factors. And if in a question it is asked how temperature affect rate of evaporation, then in this question you have to explain only temperature effect. So it can come in any form. Then these are the physical quantities and these are the units and the symbol. It's one mark question. How can we measure that particular quantity? What are their symbols? So I hope this is clear to everyone. This is end of chapter number 1, matter in our surroundings. And if you have any query, if you have any doubt, you can ask and write down in the chat box. Yes, I'm waiting for your response. Okay. Yes, I'm waiting. Yes, you can write. Yes, children, if you have any doubt, you can write. Okay, so why do we use D? See, D is the density. D represents the density and the density is mass upon volume. So density is mass upon volume. And volume is the space occupied by the substance. Yes, I'm just reading your queries. Yes, if you have any doubt, you can ask. Okay, Ritik. Okay, now I ask one question to you. What will happen if there is increase in temperature? What is the effect of increasing temperature on the rate of evaporation? If we increase temperature, how it affects the rate of evaporation? Yes? Yes, please answer. Yes, the rate of evaporation also increases. They both are directly proportional to each other. So I hope you like this session and the topic is clear to you. And I'm waiting still. If you have any query, you can ask. Okay, so thank you everyone. This is the end of this chapter number 1 now. And if you have any query, you can ask in next class also. Thank you all of you.